Good morning, students, and welcome to the session of Unit 4 Harmonics. This is video number 8. So far, we have covered in all 7 videos where we have discussed various basic fundamentals of harmonics. We have seen, to summarize, that harmonics are integer multiple of fundamental frequency. Harmonics can be used, harmonic analysis can be used where there are nonlinear loads. Using Fluke analyzer, we can measure harmonics or Fluke equivalent or any other harmonic analyzer or PQ analyzer which is conforming to IEC 519 can be used for harmonic measurements. Then we have seen that what are the detrimental effects of harmonic distortion. These detrimental effects are overheating, failure, incorrect reading, undue tripping, and so on. The equipment like motors, transformers, circuit breakers, generators, they fail because of harmonic problems. The system improvement devices like a shunt capacitor, FC, APFC panels, or even synchronous condensers are also victim of harmonics a number of times. Therefore, it is necessary to mitigate harmonics. Harmonic mitigation we will study in details in Unit 5 after completion of this unit. And harmonics are first analyzed, measured, and then the design for filter is made. So this is how mitigation is done. There are various ways of mitigating harmonics that we'll see later, like oversizing of conductor or using reactors or using zigzag transformers or the best way is filters. So we're going to study all these details in our next lecture. Now today we'll study what are the effects of harmonics in EHV network. As you know that EHV network is the network having system voltage above 66 kV. The examples of EHV levels are 66 kV, 110 kV, even 100 kV, 132 kV, 220 kV, 400 kV, HVDC 500 kV, which is plus minus 500 kV, and now it is 765 kV, which is the latest voltage level in Maharashtra. So, what are these problems of harmonics in EHV network, and particularly cogeneration plants? What are the effects of harmonics? That we'll be going to study. So, in this way, we'll start with HVDC systems. The HVDC systems are in service in Maharashtra since 1994, and lot of developments in HVDC technology has taken place since time to time. As you can see here, that there are converters which convert from AC to DC because generation is AC in Maharashtra and it is converted into DC using converter. From converter there is a HVDC transmission, and at the receiving end there are inverters that convert DC to AC. Now while during conversion they are using 12 pulse or even higher capacity bridge rectifiers which generate considerable amount of harmonics. Therefore, it is important to provide harmonic filters. So, if you consider converter, then at both the side, AC filters and DC filters are installed so as to mitigate these harmonics. We will be studying basics of filter in next unit when we will come to mitigation techniques. At that time, I will talk in details about filters. Similarly, at inverter end, at the other end, it is also converting from AC to DC, DC to AC, and at the both side of inverter, the AC filter and DC filters are provided. So in this way, the HVDC harmonic system makes use of harmonics at both the ends, AC as well as DC. In Maharashtra, the HVDC link is existing as a bipolar link between Chandrapur and Padge. Chandrapur is the super thermal generating station, and it is having the capacity of more than 2000 megawatt. Therefore, it is coming under the category of super thermal power generation. It sends this power over a bipolar link to Padge. So Padge is 400 kV station which is the load center for Mumbai and not western, but Mumbai Pune area. Therefore, about 750-kilometer line from Chandrapur to Padge is laid for HVDC transmission. So the problem of harmonics is observed in HVDC as we have discussed, and therefore filters of AC and DC types are installed at HVDC plants. Coming to windmill also, which is not an EHV part, but it is coming under renewable energy sources or non-conventional energy sources. In Maharashtra, there is a wind generation of more than, I think, when I was there in Satara, it was more than 3000 megawatt. To now, it has been about 4000 megawatt. So, windmill generators are driven through electronic devices, which are electronic controllers, which are non-linear. Therefore, lot of non-linear loads are there in windmill installations, and therefore the problem of harmonic arises. One sample study was conducted at different places like Vankusode, Kauthi Mahakal, Supa, Dhule, having different utilities of Suzlon, Innercon, Vestas, and so on. So the THD current was found to be very high, of the order of 3.8 or 4.2 or even 3.07, and it was necessary to provide filter at this installation. Although it was in limit as per TDD definitions, but still it is required to provide harmonic filter at these ends. Percent THD for voltage, on the other hand, is lesser. It is within the permissible limit of 5% as per IEEE. It is 1.5 at One Custode Suzlon, 1.4 at Innercon, Vestas 1.9 at One Custode, all the three projects. Kaute Mahakal in Sangli district, it is Suzlon 1.7%, Innercon 1.45%, and in this way, Supe, it is Suzlon site having 2.01%, and Dhule, Suzlon site 1.98%. So in this way, the voltage harmonics are within the permissible limits, but it is necessary to take care of current harmonics, which may exceed if more controllers are added or if there is an expansion of system. Therefore, efforts have been taking place to provide harmonic filter at windmill installations. Then energy audit was conducted at these locations. So it was observed that Vankusade, which is in Satara district, the feeder was 22 kV windmill. So there was a higher losses of around 2.20. At that time, VTHD was recorded as 1.12%, and ITHD was 4.45%. Similarly, at Katangari feeder, 33 kV feeder was there, and the loss was 2.25%. 1.52 is the voltage distortion, and 4.05 is the current distortion. Kaute Mahakal 33 kV feeder, the loss was 1.56%. Voltage and current distortions respectively are 1.12 and 3.85. Supa substation 22 kV windmill, 1.67 is the percent loss, and voltage and current distortion is measured as 1.84 and 4.67% respectively. Dhule is having again 22 kV feeder at windmill feeder it is called, and the percent loss was 1.89%, 1.67 and 5.01 are the limits for THD. So in this way, the energy voltage was conducted and these findings were noted at that time. Now if you look at the chart, we'll see that the highest loss is 2.25%, which is Ghatnangri feeder. So it is observed that the THD is also higher. So THD and losses are going hand to hand. Not exactly it is above the limit, but to some extent it is more than 4, which is to some extent higher. Similarly, 2.20 is the case where there was loss in case of one Kursade windmill generation. So 4.45 was also the THD. In case of Dhule, although the loss is lesser, the THD was higher. So in some cases, the losses are higher and THD is also higher, but that cannot be a rule because in number of places even losses are lesser, but still THD is higher. So it depends on how harmonics are affecting uh, kWh consumption or generation or even recording process of the meter. If the meter recording is having nonlinear load affected by high order harmonics, it also record less measurement of energy. So this is all about losses and THD. But in order to control losses, it is required to go for observing THD levels. And efforts have been made to conduct these things and take care. Now, there is a concept to install filter at substation end. But as you have studied in our earlier lectures, that if the distance is more, distance of filter and nonlinear load is more, then it will not be able to suppress harmonics to the extent it is required. Therefore, installing filter at substation will not serve the purpose. Therefore, the proposal for substation harmonic filter has been not taken into consideration. We'll study about this later in our later sections. So for today, we'll close here and we'll see some other part in our other lectures. So thank you very much for watching. In the next lecture, we'll study resonance effects in due to harmonic. So that is harmonic resonance, which is an important topic from PQ point of view. So thank you very much. See you soon.